Hello, today we're going to be exploring addition into the hundreds place using a hundreds chart. Friday the Frog is going to be providing us with questions, and we're going to be exploring 6 different algorithms to be able to come up with a solution. The first one is we're going to start off with the standard North American solution, and that is going to be by placing 456 on the hundreds chart. 2, 4, 6. 5 tens, 2, 4, 5. 4 hundreds, 2, 4. To continue on with this algorithm, we're going to be putting 198 onto the hundreds chart. Starting off with 2, 4, 6, 8. 9 tens, 2, 4, 6, 8, 9 tens, and 1 100. From this point, what we are going to do is regroup starting at the ones position. And to be able to regroup, we must take 10 ones and move it over to the tens position. And in doing so, we will have 2, 4, 6, 8, 10 ones, which we'll regroup to 110, removing the ones from the table. And this will leave us with 2, 4 ones. Regrouping the tens position, we will have 2, 4, 6, 8, 10. This will regroup into a 100, removing the tens, leaving us with 2, 4, 5 tens. This will tell us the solution is 654. Next, we are going to take a look at a second solution to this problem. And this second solution is very similar to the third solution we will be taking a look at. The first solution we will be taking a look at is 4 plus 1. And this is in the hundreds place, which tells us we will put out 5 100s. We have a 5 and a 9, which is a total of 14 tens. So we will put out 14 tens. 2, 4, 6, 8, 10, 12, 14. We will take the 6 and the 8, which is a total of 14 ones. 2, 4, 6, 8, 10, 12, 14. Now, just like we did before on the hundreds chart, what we do is we go ahead and we regroup, removing 2, 4, 6, 8, 10, again leaving us with 4 ones. And these are exchanged with our 10. We then regroup our tens. 2, 4, 6, 8, 10. regrouping to our 100. Leaving us with 2, 4, 5 tens, and 6 100s, for a total again of 654. Now, investigating algorithm number 3, we're going to do is very, very similar to number 2. Whereas number 2 we started in the hundreds position. In algorithm 3 we add the ones position. And we again come to 14. Now, as opposed to before, the key one is we put out 4 ones and automatically regroup a 10 for a total of 14. We then have 9 and 5. 9 and 5 again equal 14. And we go ahead and put 14 tiles out. But since we have 14, we are going to regroup 1 to the hundreds, leaving us with 5 tens and 4 plus 1, giving us our last group of 100s that do not require regrouping. Now, on our fourth algorithm, we're going to have to do some remembering in the middle. Our fourth and our fifth algorithms are very much the same, but number 4 requires a qualitative memory, whereas number 5 is more explicit. The important thing is we keep in mind we take a look at this number, and we see that 198 is very close to 200. So in fact, it's so close that what we need is 200 more, or just 2 more ones, and we end up with 200. So this statement becomes significantly easier if we look at it as 456 plus 200. In doing that, we will have 2 plus 4 ones for a total of 6. We will have 5 tens. We'll have 6 ones. Now, as we are going to recall, we had to add 2 ones here to be able to make this an easier problem to solve. So what we're going to have to do is we're going to have to take those 2 away. And then again we end up with our answer 654. Now, algorithm number 5 is very, very similar. In fact, it's so similar that again we start off assuming this goes up to 200. We have our 6 100s, and again we have our 5 ones or 5 tens, and our ones we would have 6. But what those are, since we had to add 2 here, we actually put -2 on as well. And to be able to represent those -2, we are actually going to be using this counter. And this means that we have -1 and -2 at the end. Using this option, what we do is we use these to cancel off the ones and end up again with the answer of 654. Now, the difference between algorithm 4 and algorithm 5 is algorithm 4 requires you to use mental math to be able to keep those 2 extra numbers that you have to take from the ones digit. Whereas algorithm 5 uses additional counters to be able to symbolically illustrate concretely on the hundreds chart that you have to cancel your goats or your ones in the 100 position. Now we're going to take a look at number 6. And we're just going to take a quick look and clean off this board. And I'm going to ask you a very simple question. Why are we doing all this work? All this work seems kind of silly. So what we're going to be doing is just say, we're going to break up this 198 into three numbers. We're going to treat this as an equation where we have 456 plus 100 plus 90 plus 8. So as a four-step addition problem. Starting off with 456, I'm going to put the four 100s on the table. We're going to have the 5 10s. And we're going to have the 6 1s. For 456 on the hundreds table. We are now going to add 100. So add 100 is a pretty simple operation. We're going to go ahead and add 90. Now we could go directly and count 9 more 10s and then regroup, or we can remember that 9 is the same as 10 minus 1, and if we have a 10 we need to regroup that 10 over and we need to subtract 1. So we could subtract 1 and regroup to 100 right there. To finish off this equation, we can take 8. We're going to add 8 more 1s. Now again, we're going to remember that 8 is 10 minus 2, which means since we have a 10, we can regroup to a 10 and take the minus 2 away. And using this algorithm, again we end up with 654. Now to continue on this exercise, what we're going to be doing is we're going to be switching our equation over to multiplication. And we're going to be using the hundreds chart to be able to illustrate repeated addition solutions to this equation from Freddy the Frog. The first algorithm we're going to take a look at is going to break 132 into 100 plus 30 plus 2. The first algorithm is going to take the 3 and multiply it by 100. 3 times 100 is 1, 2, 3, or 3 100s. 1, 2, 3. We're going to have 3 times 3 10s. So that means we're going to have 3 groups of 3 10s for a total of 9. We're going to look at the last digit. We're going to see 3 times 2, which is going to be 3 groups of 2, giving us a total of 396 for this algorithm. Again, we can also take a look at its 2 groups of 3, 30 groups of 3, and 100 groups of 3 instead of 3 times 100. We're going to take a look at the second algorithm, which is very similar. But instead of starting with 100, we're going to start with the ones digit. So the 3 times 2, or 2 groups of 3, we're going to take a look at 1 group of 3 and 2 groups of 3. Again, this can be repeated addition as we have 3 plus 3. We're going to take a look at 3 times 30. Note the place value and the value of this for a total of 3 groups of 3. And then 3 groups of 100 or 100 groups of 3. And again, we discover the answer is 396. Having said that, it should be 396. The and is reserved for the decimal point. Thank you, and have a great day.